Okay, so volumes of revolution. In this unit type thing, there's going to be 3 different ways we can find volume. The first one is cross-sectional volume. So that is not on here, but let's just add it on as a little bit of a review. What is special about cross-sectional volume? Like, what is it?
It's where they share something.
What do they share?
The middle.
What do you mean by that?
Like the area, like they share.
Are you talking about the diagram or this?
Oh, I was talking about the diagram.
We'll do this part first. So cross-sectional, this was the Play-Doh activity. How did these shapes, what are they? They're stacked on top of each other. What formula gives you the volume of it? Integral of?
A of x.
Exactly. What does A of x stand for? Area of a cross-section. So these ones were like, you have a whole bunch of semicircles. That if you were to cut that shape, you'd see like a semicircle on your shape. What type of top would a semicircle have?
Circle.
Oh, yeah, it would be rounded. What if it was like a cross-section of a triangle? What kind would that be? Chunky. A square. Flat. One thing for you to like keep in mind on all of these, what are the bottoms of all of these shapes? Flat. So this one has a flat bottom. That's kind of like the distinguishing factor, is that it's like you have a piece of paper on your desk and the shape is placed on top of it. So it has a flat bottom and then whatever volume we're making comes up. The other type is a volume of rotation. So if you're rotating it, is it going to be a flat bottom anymore? No. I'm gonna put this one, like these are together. We have discs and we have washers. How is a disc different than a washer? Or vice versa?
Washer has a hole in it.
Yep, this one has a hole in it. What formula gives us the volume of a washer? What goes in front since it's rotating and it makes a
Pi.
pi, yep, because it's really just a circle. And then circle,
So like half.
Something squared plus something squared.
big squared minus little squared. dx, dy, whatever. What makes it have that hole? This is kind of like an extension type question. In terms of the axis of rotation, is it touching that axis or not touching it? Not touching it. So axis of rotation. Okay, a disc. We can kind of just go like opposite of all of this. A disc doesn't have a hole in it. It's more like a hockey puck, just a solid figure. What makes it not have that hole in terms of its axis of rotation? It touches it. It touches the axis of rotation. What's the formula for a disc? Still has a pi. This one is kind of like a cheat way. Technically, could we still do big squared minus little squared? But the fact that it's a disc and not a washer, that little, what is that little probably going to end up being every time?
0.
It's going to be 0. I personally kind of set everything up as just big squared minus little squared because then it's just one formula you have to use. If it is touching its axis of rotation, then it's just 0 because it's 0 spaces away. The one thing that these have in common, the biggest thing that they have in common, is when you guys find these volumes and you draw in that little representative line. And what I mean by that is if we are rotating around the x-axis, which way do I draw that line? Do I draw it vertically or horizontally? what do we need to be in terms of to our vertically? So when you guys are rotating something with these, your axis of rotation has to be perpendicular. So we are perpendicular to the axis of rotation. That's the biggest thing that they have in common. Whatever you are rotating around, that little representative line that you think of, like that's rotating around and making a disc, and then the next disc, and so on and so forth, you need to be perpendicular. So the issue with this is that it makes things a little bit goofy. We're gonna do one review problem, and it's gonna kind of be the worst type of review problem because you're gonna see like why this method is a little bit weird. So sketch a graph to represent the region bounded by the given graphs that is revolved about the y-axis. We're gonna leave our answer in terms of pi. X squared plus 2. Where is that? Up to. Y equals 0, x equals 0, and then the line x equals 2. So what region are we looking at? This little guy? So when you guys find your regions, make sure that it is touching every given constraint. So this one, since it's up to, it is bounded by both of the axes plus that vertical line plus the line. And we want to revolve it around our y-axis. So if we are revolving it around the y-axis, which way does this line need to go? Up and down or side to side? Side to side. So does anyone see the tricky part about this problem specifically? We have to be in terms of y, and what else?
It's curved.
It's a curve. Is it curved the whole way? No. So this first line, do you see how I'm bounded by the line 2 and the axis? If I move and draw my line up here, am I still being bounded by those same 2 constraints? No. So when you guys find volumes of revolution, you have to have a consistent line. So since we're doing this in terms of y, your big minus little always needs to be the same. Our big is 2, but over here, the little is the axis. Once we move up to this upper portion, do you see how now the little is the line? So the reason that this one is weird, is this a disc problem, a washer problem, or both? It's both. The bottom portion, so if I just look at this bottom portion, do you see how that is a disc? And then the top portion of it, do you see if you rotate that around, it's going to be open, so it's going to be a disc and a washer. So when you rotate this, it essentially looks like a bowl, except for it has like a really tall bottom on it, so it's like on a pedestal, and then you have your bowl. So do you see how it's a disc and a washer? Because of that, you need to do this in 2 parts. I'm just going to put a dotted line right here so we can see like, okay, here's the disc portion. The disc portion is a pi. What is the big? How far is the big away from our axis of rotation, which is the y-axis? 2. How far is our little away from the y-axis? 0, so you don't need to write it. And then we need to know, where does this region begin and where does it end? So where does this region begin?
0.
Where does it end? So that's just the bottom portion. That's like the pedestal portion of this. Plus, now we have to do the washer portion. So now we're looking at the top half of it. Still is a pi. It's kind of like it's just its own problem now. Since we're going side to side, instead of thinking of this as y equals x squared plus 2, we need to solve it for x. So what equation are we looking at? technically that square root should have a plus minus sign. However, when we look at our figure, do we have both sides of it? No, so that's why we can just say it's the positive side of it. This figure, where does it begin at? Where does it end at? So we know our x equals 2 over here. So plug in 2 squared plus 2, 6. So our big, how far is our big always going to be away from that axis of rotation? 2. Like this big portion is still 2 away. And now our little portion is being bounded by the line, which is just our square root. When you guys are counting from your axes, if they are like the x or y axis, you don't need to adjust them at all. So when you say the square root of y minus 2, it's counting out from the y axis, so that's why we don't need to do like 2 plus or 2 minus or anything like that. When you are rotating around an axis, you should be able to just use those equations. To leave your answer in terms of pi, you just grab your calculator, plug this in. Grab your calculator, plug this in. So I don't like, some of you do one, some of you do the other. And if you get an answer, just holler it out. Anyone get the disk part? 8, and then we got our pi. What about the washer part? 8 again, so 8 pi. So total, what is the volume of this region?
16
Good. If you don't have units, you don't need to move on.
Yeah.
You can just leave them. All right, so this problem is weird because you see how we have to break it up into 2 portions. The reason we have to break it up into 2 portions is the big minus little was not consistent. And that's kind of like the key part whenever you guys are finding these, is your big minus little should be consistent, because then you can say it's always this equation minus this equation. When you guys are doing discs and washers, you have to be perpendicular to your axis of rotation. So wherever you are rotating it around, you have to be perpendicular to it. Do you guys have any questions on disc/washer method? Okay, we are adding on the last way we are going to find volume, and it is called the shell method. So what the shell method is it's pretty much the same thing, except for what a disc or a washer does is it takes like one rectangle and it rotates it around, and that's how you create your figure. It's like one little rectangle rotates around, and you just keep doing that. What a shell method does is instead of a rotation, it's like it takes a single like layer and it folds it around into a cylinder, and then it adds on the next layer, and they just keep on adding on a layer upon a layer of a cylinder until it gets to be a volume. So, have you guys ever seen the videos of like M&Ms or Skittles or stuff like that being made when they go in the drums and then they like spray them with stuff? So it's like you're spraying on, it's like paper mache. You like build on one layer, build on the next layer, and you just keep going on layer by layer. So shell method, literally they're like adding a shell, adding a shell. You can get the exact same figures either way. It's just a different method of doing it. Can you put that away, please? For this, it is a little bit of a different formula. I put all the like technical stuff on here so that if you guys want to see it, you can. But what it all kind of boils down to is you're taking a cylinder and you're laying it on its side. So it's like if you have a net of a cylinder, you have your, I don't know why I drew that. Pretend like that part isn't there anymore. This is like the size of a cylinder. In terms of a cylinder, this is just going to be your height. In terms of a cylinder, how does that relate to a cylinder? Like, what would that portion of that be? So if I like took my water bottle and I had this wrapped around it, my height is up and down right here, but the part that actually wrapped around the circle, how does this relate to the circle itself? Like, what does it have to also be the same as? Yeah, the circumference. So this portion of it has to wrap around that top portion of the circle. So if you look at this right here, the 2 pi, I don't want to mess this up, r, isn't that just circumference of a circle, 2 pi r, times the height. Because this is just your lateral area of just the rectangle portion. So it is like a length times a width, except for because we're essentially making a whole bunch of cylinders, that top portion of it has to wrap around a circle's circumference. So, in terms of shells, the reason we are going through shells is that they get to be parallel to your axis of rotation. The formula for a shell, 2 pi, because again, it's coming from a cylinder. Like, we're wrapping around a whole bunch of outer parts of a cylinder. And then here's where it's going to look a little bit different. It's x, f of x, dx. X is your radius, aka the distance from your axis of rotation. F of x is your height, which will probably be your big minus little. So 2 different ways we can rotate something or get a volume of revolution that doesn't have a flat bottom. The first one is we rotate around, we have our discs and our washers. The second way is shells. Have you guys ever made something with like paper mache where you like lay a layer of paper down and then the next layer and the next layer? So that's what you're doing. You're like wrapping it around, and you just keep doing that. Formula wise, it comes from the lateral area of a cylinder. X is your radius because that's just how far out you're going to be. F of x would be the height of it. Biggest perk is now we don't need to ever rewrite things in terms of y if you don't want to, because now you can be parallel rather than perpendicular. We're going to do 3 examples with it, and the first one is going to be the one we actually just did, except for now we're going to do it as a shell. So at the end of the day, shells, discs, and washers can all be used interchangeably. It's just a matter of like which one might be a little bit easier than the other. Your method is never graded. So even on the AP test, they do not require you to do shells, but if you do it as a shell, it's not going to be counted wrong. Shells are just going to be a little bit easier because now when we have this figure, if we want to rotate it around the y-axis, now we can be parallel rather than perpendicular. And if I'm parallel rather than perpendicular, do you see how the big minus little is the same every time? Every time I draw on that vertical line, it's always the same equation on top, always the same equation on the bottom. So, formula-wise, 2 pi, now you are in terms of x. So, whenever our lines go up and down, we're in terms of x. X is how far you are away from it. So, whatever like random line you think of, I think this is kind of weird to see, like this line right here. Do you guys agree it's its x value away from the axis of rotation? It doesn't matter where I put that line, however far away it is always just going to be its x value. So our radius is just an x. That's fun. We'll go with it. And then its height. What equation is bounding this height? Yeah, x squared plus 2. And then technically, what can we take away afterwards? Like, what's the lower bound of it? 0. So it is still that big minus little. You're in terms of x. So this region begins at 0. where does it end at? 2. So again, same end result, except for instead of thinking of us rotating around like a little rectangle, it's like we're building it out from the middle, layer by layer. When you punch this into your calculator, just the integral portion, what do we get from just the integral portion? From just this part, shouldn't it be 4?
I see.
I got it.
Did someone actually punch it in and get 4?
I see.
I mean, it makes sense because if it's 8 times 2, it's 16.
Oh,
What's the very gap?
I forgot it was 2 portions we had to do last time. Like, you guys got 8 last time. You have to get 4 now. I'm sorry. Yes. This is why I need you guys. I confused myself. So we get the same answer. Last time we had to do it in 2 figures because you have to be perpendicular. If you do it as a shell, you can be parallel. So I don't know if you guys noticed when some of my answer keys, like there'll be 2 different answers because it says shell for one of them. Shell is just a different way of doing it. Honestly, the only time you guys should probably be using shells is if it saves you from rewriting it in a form that you are not given. Okay, use the shell method. We're going to use the shell method to find the volume that is bounded by those equations. And first we're going to revolve it around the x-axis. So x equals y minus 1 squared. Where is y minus 1 quantity squared going to look like? Where's it going to be? All that stuff. Open to the right, and then that minus 1, since it's inside with y, how's it going to move? Up. But, okay, so technically this should be like the upper and the lower, but it's also being bounded by the line y equals 1, x equals 4, and then x equals 0. So we're looking at this region right here, and we are going around the x-axis. So here's the perk of this. If I were to do this as a disc or a washer, I would have to be up and down because we would be perpendicular. The way that this is written though, do you see how it's given to us in terms of y? So if instead we use a shell, now we get to keep it consistent with that whole, how it's written. So if our rectangle goes side to side, we need to be in terms of y. This is given to us in terms of y. A shell is just going to be 2 pi radius times your height. So we got our 2 pi. Where does this region begin? Where does this region end? How do we figure out where it ends? Yeah, or x equals 4. So 4 has to equal this. Square root it. So 2 equals y minus 1. So then what's our upper bound? 3. Okay, so from your axis of rotation, what value is going to give our radius? It's no longer going to be x. What is it going to be now? Y. So whatever line we're at, the y value of that line is how far away it's going to be. The height of it. So our height, our big minus our little. What is our big function? Minus, what is our little function? Yeah, y minus 1 squared. There is no like big squared minus little squared. The squaring on the washers is because you're essentially making a circle every time you rotate it. This is just the outer part of a cylinder. So these ones do not get squared. It's a different formula. The 2 pi in front does not get squared. Let's go to 4 decimal places. If you guys don't agree with this, let me know. 58.6430?
Yep. For 643.
What's after the 0?
6.
Oh.
she likes it.
So it should be 3-1? Do other people get 3-1 or 3-0? You got a 1-2? All right, do you guys have any questions on that one?
Just multiply
All right, last one. Now it's the same figure, but we are rotating it around the line y equals 3. So if we do this as a shell, which way do our lines go? Up and down or side to side? Side to side. Here's the nice thing about shells, is it doesn't get as like funky looking, I guess, because it is still 2 pi. Our region still goes from 1 to 3. Our big minus little for our height stays the same. What changes is the radius. Because if we say our radius is y away, it's going to count from the axis up to y. But the actual distance from our axis of rotation is the other side. So how do we get that other side? Instead of just saying y, just like the other times, what do we have to do to it? How long is this whole portion? 3. Do I want the portion underneath it?
No.
No. So I take away y. Just like on the discs and washers, when you're revolving around something that is not an axis, you might have to do a little bit of adjusting on it. I think this one has less adjusting because when you find your height, that big minus little, you're just looking at the figure in front of you. The thing that's changing here is the radius, because that's however far away you are from your axis of rotation. Don't know why I left this one as an exact answer. I got 40 pi over 3. So shell method, not necessary, but if you notice that something can be done with the shell method, it actually saves you a decent amount of time because you don't need to rewrite everything. And it can save you, like this one right here, I think is the best example. If it's consistent one way, then you don't need to break it up into 2 sections.